In this lesson, we will address one of the fundamental topics in finance, bank loans, and the way their payments are structured. More specifically, I will show you how to perform calculations that are typically made for you by bank employees. It is a great idea to be prepared before your conversations with bankers, as this will put you in a stronger negotiating position. Furthermore, you will be able to distinguish between capital and interest payments, something that most people aren't able to do. We will consider a bank loan that involves constant monthly payments through its entire duration. Let's take our example from before. There is a person who wants to buy a house that costs $300,000. After talking to some of his friends and seeing several mortgage loan advertisements, he concludes that the current market rates are between 2% and 4%. So he decides to make his preliminary calculations by using a 3% rate. He wants to repay the loan in 10 years by making equal monthly payments throughout these 10 years. Here's the million-dollar question. How much will his fixed monthly payment be in order for him to be able to extinguish the loan in 10 years? There are two ways to calculate it, an easy way and a hard way. Which one do you choose? Okay, we'll use the easy way. But before, I want to explain to you with a few words the mechanics that stay behind the hard way. In our previous lesson, we saw the formula that allowed us to calculate the future value of an annuity. Well, here is the formula for the present value of an annuity. It is almost the same except for a small difference between the two actuarial factors, S and A. The manual calculation shouldn't be too hard after all, because we have all the inputs that are necessary, the interest rate, I, and the number of periods, N. We can easily solve the equations by substituting the numbers and solving for the only unknown, the monthly payment, R. In practice, things are simpler. Microsoft Excel allows us to calculate the equation much faster. Let's type our inputs on this sheet. The number of periods during which the loan will be repaid is 120, given that the person will make equally monthly payments for 10 years. The interest rate that he will have to pay for borrowing the money is 3% on an annual basis. Let's divide it by 12 in order to obtain the monthly interest rate. Okay, very good. And finally, the amount that is borrowed is $300,000. We have all the necessary inputs that would allow us to calculate the monthly payment for the loan. The Excel formula for this calculation is PMT, as in payment. I will type it into the formula bar and will select each of the inputs. Okay, our formula is ready. The borrower will have to make a monthly payment of $2,896 for 10 years in order to repay the loan. Let's go a step further and disaggregate what portion of each payment is interest, principal, and how much is the remaining debt. Let's create 5 columns. Period, payment, interest, principal, and finally, residual debt. We can improve the formatting of the columns a little bit. Okay, that's better. The first column will indicate the number of respective payments, 1, 2, 3, 4, and so on, up to 120. We already calculated the amount of each of the fixed payments. Here it is. I'll link to the cell and then fix its references in order to be able to copy it to the last row of the table. Our next task is to disaggregate this payment into 2 parts, interest rate and principal. In the first period, the amount of interest that will be accrued is based on the whole amount of debt that is drawn, and given that no payments have been made, we have $300,000 times the interest rate, which equals $750. The difference between the payment and the amount of interest payments is the amount of principal that is repaid. In the last column, we can calculate the residual debt that remains after this payment. Okay, good. Let's do the same thing on the row below. I'll multiply the interest rate by the residual debt, fixing the cell references of the interest rate. Then, I'll take the difference between the payment that was made and the amount of interest. This is the principal that will be repaid in this period. Okay. Let's calculate the amount of residual debt by taking the difference of the amount that was due before this period and the residual debt after this period. Here's our residual debt after period 2. We can copy these formulas to the last row of the table. As you can see, the residual debt at the end of the loan life is exactly 0, which means that we worked correctly. This is how we can calculate an entire loan schedule, an exercise that allows us to plan better and understand exactly how much and for what we are paying.